Disclaimer: this podcast is for educational purposes only and is not medical advice. Always consult with a qualified healthcare provider before starting any peptide therapy or supplement routine. Today we are going to spend time diving deep into the fascinating world of Epithalon. This peptide has sparked curiosity for decades because of its potential links to aging, longevity, and cellular repair. The story of Epithalon begins in Russia, where it was first studied by Professor Vladimir Kovitsin. He was a scientist who dedicated his career to researching peptides and their impact on human health. Epithalon, also known as Epithalon or Epithalon, is a synthetic version of a naturally occurring peptide called epithalon, which is produced in the pineal gland. The pineal gland is a small organ located in the brain. It plays a role in regulating circadian rhythm, sleep, and hormone production. What makes Epithalon so interesting is its suggested ability to influence telomerase activity. Telomerase is the enzyme that helps maintain telomere length. Telomeres are protective caps at the ends of chromosomes. They shorten as cells divide over time, and this shortening is closely associated with aging and cellular decline. By potentially supporting telomerase activity, Epithalon may help extend the lifespan of cells and reduce the negative effects of aging. Many people are intrigued by this connection because it provides a biological explanation for why this peptide might contribute to longevity. Beyond telomeres, Epithalon has also been studied for its role in balancing hormones, particularly melatonin production. Melatonin is essential for regulating sleep-wake cycles. The pineal gland plays a central role in its release. As we age, melatonin production declines. This decline is tied to disrupted sleep, poor recovery, and even immune dysfunction. Epithalon's ability to support melatonin levels is one reason why it has been studied in the context of healthy aging. Let's talk about how Epithalon has been used in research. Scientists have explored its effects in animals and in some small human studies. The results are promising but not yet definitive. In animal studies, Epithalon has been shown to increase lifespan, improve markers of oxidative stress, and enhance immune function. Some reports suggest better resilience to stress and improved overall vitality in older animals. In humans, research is still limited. However, there have been observations that Epithalon can help restore circadian rhythm, improve sleep quality, and support immune balance. While these findings are intriguing, it is important to remember that much of the evidence is still preliminary. Another important angle is the possible relationship between Epithalon, cancer risk, and DNA stability. Aging and cancer are closely linked because the same processes that shorten telomeres also destabilize DNA. When DNA becomes unstable, mutations accumulate and cancer risk rises. By stabilizing telomere length, Epithalon may play a protective role. Some research in animals suggests it could reduce tumor development. But translating that to humans is still uncertain, and more studies are needed before any firm conclusions can be made. One of the more practical reasons people explore Epithalon is its reported effects on sleep. Many users describe deeper, more restorative sleep, more vivid dreams, and improved recovery when they use this peptide. Since sleep is such a foundation of overall health, this alone makes Epithalon appealing to many people interested in aging gracefully. Let's take a moment to talk about dosing. Though this is not medical advice, research studies often use cycles rather than continuous use. A common approach seen in the literature is a course of injections lasting 10 to 20 days, repeated once or twice per year. The idea is that a short pulse of the peptide may be enough to trigger lasting effects on the pineal gland, telomeres, and circadian rhythm. Researchers have experimented with both subcutaneous and intramuscular injections, and sometimes oral forms. Injections, however, are the most studied. Again, it is important to emphasize that these practices remain experimental and are not approved by regulatory bodies in most countries. Epithalon also raises interesting questions about biological age versus chronological age. Chronological age is the number of years you have lived. Biological age, on the other hand, reflects how well your cells, tissues, and organs are functioning. Some research suggests Epithalon might reduce biological age markers, meaning the body functions more like that of a younger person. This idea of shifting biological age is why longevity researchers are so fascinated by the peptide. It suggests that aging is not fixed, but can be influenced by molecular tools like peptides. Epithalon is often discussed alongside other longevity strategies, such as caloric restriction, intermittent fasting, antioxidants, and other peptides like thymosin alpha-1 or GHRH analogs. The idea is synergy, targeting multiple pathways of aging at once. While Epithalon may focus on telomeres and melatonin, other compounds address inflammation, immunity, or growth hormone secretion. Together, they create a more comprehensive anti-aging strategy. Safety is another big question. So far, research suggests Epithalon is generally well tolerated in studied doses, with minimal reported side effects. Some people report mild injection site irritation or temporary fatigue. But without large, long-term human trials, safety cannot be guaranteed. Beyond aging and sleep, researchers have looked at Epithalon's possible effects on vision, immunity, and even skin. Some studies suggest it may improve retinal health and slow age-related vision decline. Others point to immune regulation in older individuals, where the immune system becomes less responsive with age. As for skin health, some believe that stabilizing telomeres could indirectly benefit collagen production and elasticity. While these are interesting ideas, they still need more scientific proof. When you zoom out, Epithalon represents a key piece of the peptide puzzle. Peptides are short chains of amino acids that act as messengers in the body. Each has specific targets and functions. Epithalon is unique because it works on the genetic level through telomerase and on the hormonal level through melatonin. Over the years, anecdotal reports have piled up from people experimenting with Epithalon. Many describe improved energy, sharper mental clarity, and faster recovery from workouts. Others notice improved mood or resilience to stress. While exciting, these experiences should be viewed as personal stories, not hard scientific evidence. Accessibility is also a challenge. Epithalon is not an approved medication in most countries. Many people who try to obtain it from research chemical suppliers or international clinics. This raises questions about quality, purity, and consistency. It underscores the importance of caution and of sourcing only from reputable labs. Epithalon also brings up ethical questions about longevity research. Should humans try to significantly extend lifespan? And if so, how do we make sure quality of life keeps up with the added years? Peptides like Epithalon force us to think about what it means to age and how science might reshape that process. As a symbol, Epithalon stands for the idea that aging is not set in stone. It opens the door to possibilities that once seemed like science fiction, slowing or even reversing aspects of aging through molecular interventions. The conversation about Epithalon is really a conversation about the future of medicine and human potential. Some researchers even see peptides like Epithalon as part of a new era of personalized healthcare. Treatments may one day be tailored to each person's biology, genetics, and lifestyle. Epithalon could be one of many tools that help people not only live longer, but live better and healthier. As we move toward the end of this episode, let's recap. We covered the discovery and origins of Epithalon. We talked about its possible mechanisms, including telomerase activation and melatonin regulation. We explored its potential role in aging, sleep, immunity, cancer risk, and even vision and skin health. We also discussed protocols, safety, accessibility, and the ethical questions surrounding longevity science. While research is still in early stages, Epithalon continues to capture attention as one of the most intriguing peptides for healthy aging and lifespan support. Disclaimer: this podcast is for educational purposes only and is not medical advice. Always consult with a qualified healthcare provider before starting any peptide therapy or supplement routine. Thanks for listening. Keep learning and stay curious.